Hi, this is Algebra's Module 2, Lesson 5, Half Interested. So here we're building off of what we learned about with those geometric meanies in Lesson 4. So this time we have Carlos and Clarita, Martinez twins, have run a summer business every year for the past 5 years. The first business, as a neighborhood lemonade stand, earned a small profit that their father insisted they deposit in a savings account at the local bank. When the Martinez family moved a few months later, the twins decided to leave the money in the bank where it's been earning 5% interest annually. So that means every year. Carlos was reminded of the money when he found the annual bank statement they had received in the mail. Remember how Dad said we could withdraw this money from the bank when we were 20 years old? Carlos said to Clarita. We have $382.88 in the account now. I wonder how much that will be in 5 years from now. So, knowing what we know from just what Carlos said, how much they have, and the 5% interest, how can the twins figure out how much the account will be worth 5 years from now when they're 20 years old? So, describe a strategy and calculate the account balance. So, I'll leave that to you to figure out a strategy. There's multiple ways to do that. Think for a moment what you would do. Carlos, now that you've kind of got a theory, Carlos and Clarita have two different ways of solving this. Carlos calculates the value of the account 1 year at a time. So he knows that we're starting with the 382.88 over here, and he can find the value of the account for the first 4 years if he does it 1 year at a time. So he's taking 382, 382.88 times 105%, so the full 32.88 the first year, and then 5% for the original amount plus the 5% he gets for the year, and that comes up with the 402.02. So if you take that 402.02 and times it by your 105%, so the original 402.02, and the 5%, you come up with the 422.12. And so he keeps doing that. 422.12 times 1.05 gives us the 443.23. And then we'll do two more times. So 443.23 times 1.05 equals 465.39. And now if we take the 465.39 times 1.05, then we end up with 488.66. So I'm going to put that in here, 488.66. So that's one way of solving it, doing it year by year and just putting it on there. Now you could take 382.88 times 0.05, the 5%, and then add the 382 back. But we learned from last module that we can summarize it in a 105% because you're getting the original 100 and then you're adding another 5% to it. So we'll do that in one shot. So Clarita thinks Carlos is silly calculating the value 1 year at a time and says he could have written a formula for the nth year, then evaluated his formula with n equals 5. So Clarita's formula for the nth year, we're going to find that and then find with the nth value and then put in a 5 for it. So notice when we're doing our explicit formulas, we have what's repeating in these? Well, we have the 105, 1.05, 1.05, 1.05. So our explicit formula is always our first term, f of n, equals our first term is 382.88 times what are we repeating? It's a geometric sequence. It's multiplying. 1.05 is what we're repeating over and over. And because it's a times 1.05 each time, we're taking it to the n. Now, we don't need the n minus 1 because our starting balance, our 0 year, is 382.88. And so then when I go to fill in, here's where I can fill in a 5 and solve for that. So if I'm going to come down here, f of 5, because I want the 5th year, is 382.88 times 1.05 to the 5th power, and that does give me 488.66. So Clarita's works same way as Carlos's, but we're utilizing that formula that we have, that explicit formula that we use when we're making geometric sequences. All right, so let's scroll on down. Carlos was surprised that Clarita's formula gave the same account balance as his year-by-year strategy. Explain in a way that would convince Carlos why this is so. That's kind of similar to what we were doing before. Each year, he was multiplying 1.05, so 105%, and he did it 5 times. So essentially what he did was he took 382.88 times 1.05 times 1.05 times 1.05. So that was the first year, the second year, the third year. Here's the 4th year, and then the 5th year to get the 488.66. So essentially, he took 1.05 times 1.05 times 1.05 times 1.05 times 1.05 is the same thing as that 382.88 times 1.05 to the 5th power. So I can't remember how much money we earned that summer, said Carlos. I wonder if we can figure out how much we deposited in the account 5 years ago, knowing the account balance now. So with this one, keep in mind it's still that 5% interest each year. And we're going to see here, he continued his strategy to go back 5 years. So what is he doing to find this to go until we get to negative 0.5? Well, let's see what we're doing in the table to do this. Well, to go from 382.88 to 402.02, we multiplied by 1.05. To go from 402.02 to 422.12, we multiplied by 1.05. Well, basically, we have to figure out what do we multiply by 1.05 to get the number we currently have. So that's going this way. If I take this and I want to go backwards, what do I have to do to 422.12 to get back to 402.02? Well, I actually want to do the opposite of multiply. I want to divide by 1.05. Just like if we would go 2, 4, 8, 16, 32, going this way is a times 2, but going that way is a divide by 2. It's just opposites, mathematical opposites. So to go backwards, I want to take 382.88 divided by 1.05, and that got me the 364.65. So again, I'm going to take that 364.65, divide by 1.05, and now I'm going to get 347.28. So 347.28. 347.28 divided by 1.05. That's going to get me 330.75. 330.75. Keep going. 330.75 divided by 105 then gets me 315 even. Just going to put a 315 in there. 315 divided by 1.05 is essentially it's 299.999. So we're going to round that up to 300. Basically, 5 years ago, they started with $300. And we'll go ahead and put in our original down here for, we have that 488.66. Yeah, 488.66 is our last one. So working backwards, that's how Carlos, he did his 1 year by 1 year at a time. Now Clarita says, going forward was I multiplied 1.05 over and over. She's saying I'm dividing 1.05 5 times. So that's the same thing as a -5 exponent. Remember, negatives in the exponent turns it into a division, turns it into a 1 over times the reciprocal. So Clarita is going to do her formula, and that's why she gets the same results. Because a negative exponent, so the -5 would mean you're taking the 1.05 to the -5th is the same thing as 1 over 1.05. So it's multiplying by the reciprocal, which is really a division to the 5th power. So it gives you the same answers as you get up there, that $300 for a start, because you're dividing it 5 times. Same idea there. All right, let's keep going. Clarita doesn't think that leaving money in the bank for another 5 years is such a great idea. Suggests they invest their money in their next summer business, Curbside Rivalry, which for now they're keeping top secret from everyone, including their friends. We'll have some startup costs, and this will pay for them without having to withdraw money from our other accounts. Okay. Carlos says we'll be withdrawing our money halfway through the year. Do you think we'll lose out on this year's interest? No, they'll pay us for the half year's portion of our interest. So that's how banks do. They just keep it going for as much during the year. They'll pay out when you take it out, but it's accruing each month. And Carlos wanted to know how much that would be. So calculate the account balance and how much interest you think Carlos and Clarita should be paid if they withdraw their money half a year from now. Remember that they currently have $382.88 in the account and they 5% annually. So think about how you would do that, and I'll let you come up with a strategy as to what you would do. I typically would do the geometric meanies. So I'm going to make my table that the 0 year, that was a really rough line. 0 year is 382.88. Half a year we don't know. And 1 year was 402.02. So I'm going to say that my original with the geometric meanies, because we know it's a geometric sequence, I'm going to say I take 382.88 divided, backwards. Sorry about that. 402, we take our last one divided by our first one. So 402.02 divided by 382.88, which gives me the 1.05, right? Because it was a jump going this way from this one to this one was times a 1.05. So that looks right. And now I need to see how many jumps I need to do. So 1 jump, 2 jumps. So that means I need a square root of 1.05. Well, that's about 1.025. So this is times a 1.025 times 1.025. And I end up getting 392.34. 392.34. So we'll see how this works with the rest of them. All right. So Carlos used the following strategy. This is what he did. He calculated how much interest they should be paid for a full year, found half of that, and added the amount to the current account balance. Clarity used this strategy. She substituted half in the formula of A equals 382.88 times 1.05 to the n power, what we got earlier, and recorded this as the account balance. They didn't get the same result. So let's try both and see which one we agree with from the way we did. So Carlos says, I want to take half of the amount we had. So he's going to go 402.02 minus 382.88, and that gets 19.14. So that's how much interest they got the first year. Divide it by 2, since we only went half a year. It's 9.57. And then we want to add it back to our original 383. Not drawing well. Add it back to our original plus 382.88, and that gets us 392.45. 92.45. Well, not too far off from our original. If we look at what we had, 392.34, 392.45, just a matter of a few cents. So at this point, doesn't seem very far off, but let's see what Clarita's looks like. So Clarita, let's do 382.88 times 1.05 to the half power, and she gets 392.34. Notice hers matches ours. So we are going to agree with Clarita because it matches ours. Now, how come Carlos's didn't work? Well, let's try to convince Carlos that we need to, his was not correct. Clarita's trying to convince Carlos that her method is correct. Exponential rules are multiplicative, not additive. Look back at your table. When we learned we will earn 82.51 in interest during the next 4 years. If your method works, we should be able to take half that amount, add it to the amount we have now, and get the account balance we should have in 2 years. That's a lot of words. This is the interest for 4 years. She's saying half of that interest should add up to equal our 2 years mark. So let's see if he's right, if she's right on there. So let's work through Carlos's idea. So the 82, this is what Carlos is saying, 82.51 divided by 2 would be 41.26. 41.26. So that should be 2 years worth of interest, right? If this is 4 years worth, oh, cannot read that. If the 82.51 is 4 years worth, half of it should be 2 years, according to Carlos. Well, let's take our original amount, 382.88 plus 41.26. That equals We want to know, does it equal what our 2 years amount is for 2212? So this is actual 2-year total. So that's the actual 2 years amount. We'll see if they equal. When I add this up, I get 424.14. So this does not equal our amount we had before, our actual amount. So notice how his method does not make him match up to what we've already determined should be their amount in 2 years. All right, let's keep going. The points from Carlos's table, question 2, have been plotted on the graph at the end of this task along with Clarita's function. Plot the value calculated in question 9 on the same graph. What does this graph reveal about the differences in Carlos's 2 strategies? So let's, and we're going to plot them for the half year. Okay, so I'm going to scroll to the graph. Here's our graph. Zoom out just a tad to get it to all fit. Okay, so if I plot Carlos's amount, his 1-year amount matches this 1-year amount. So let's go ahead and Carlos will put in blue. So his 1-year amount matches. That's pretty good. But his half year, let's see, 1, 2, 3, 4, 5. So we're halfway through 1, 2.5. Notice his halfway one is slightly higher than the actual. So his was 392.45, whereas Clarita's was just a hair less at 392.34. So notice how his is going in a straight line. His is in a straight line on here, and Clarita's has a tiny bit of a curve going in it. So she's got that exponential curve going, whereas Carlos has a linear direction on his line. All right. So I'm going to go back up here to where we were. Okay, so I'm just going to write in here that Carlos's graph is linear and Clarita's is geometric or exponential. All right, so your data points seem to fit the shape of the graph better than mine, Carlos conceded. But I don't understand how we can use a half as an exponent. How does that find the correct factor we need to multiply by? In your formula, writing 1.05 to the fifth means multiply by 1.05 times, and writing 1.05 to the negative 5 means dividing by 1.05 times. But what does 1.05 to the half mean? Well, Clarita wasn't quite sure how to answer Carlos's question, but she had some questions of her own. She decided to jot them down, including Carlos's question. So if we plug in 1.05 to the 1/2 as a factor, what do we get? Well, we get 1.025. Well, what happens if we multiply this answer and multiply it again by each other? It should be 1/2 and 1/2 should give you a full year's worth of interest. So 1.025 times 1.025 does equal 1.05. So what does that suggest if multiplying 1.05 to the 1/2 times 1.05 to the 1/2 is the same as multiplying by 1.05? What does this suggest about the value of 1.05 to the 1/2? Well, any number times itself, 0.025 times itself squared equals 1.05. How we undo a square is a square root. So that means the square root of 1.05. What multiplied times itself gets me 1.05, 1.025. Actually, if you look back up at our geometric meanies way of solving, isn't that what we got? Square root of 1.05 is 1.025. So we can conclude from this that our big takeaway is 1.05 to the 1/2 is the same thing as the square root of 1.05. Same answer. So different ways of writing the same thing. Keep this in mind as we move forward. Finally, it says, as Carlos is reflecting his work on this work, he notices the date in the bank statement that started this whole conversation. This bank statement is 3 months old, she exclaims. That means the bank will owe us 3/4 of a year's interest. So how much interest will the bank owe us? So let's go ahead and use Clarita's way of solving this, because that's the one we know is the most efficient. So 382.88 times 1.05 to the 3/4 equals 397.15. So that's how much they will end up owing them at the moment, because they still get more interest than what they have. So that's one reason why when we have things involving interest, keep in mind that it doesn't go up evenly like the arithmetic. The more money that's in the bank, the more interest you're going to get. So it's going up exponentially. Thanks for joining us and have a good day.